Welcome to this webinar on mobile bot defense. Let me tell you a little bit about Appdome. We are the one-stop shop for mobile app defense. We do much more than just mobile bot prevention. On Appdome, you can get a solution that will protect your apps against threats, against fraud, against malware, against cheats, and then specifically mobile bot. One of the unique differentiations of Appdome really is that we allow you to fully leverage automation. We are a build system that connects into your existing CI/CD pipeline. We have connectors to Azure DevOps, Bitrise, Circle CI, GitLab, GitHub, you name it, many more. We make it very easy for you to implement and version your security directly from inside of your CI/CD pipeline so that your developers don't have to make any changes to how they build apps. Another key differentiation of Appdome is Appdome provides you also with the intelligence, real-time intelligence into all the threats and attacks that are leveled against your infrastructure. And so that you have both a way to prove that your defenses are actually working, but you can also see an emergence of new threats and attacks before they can be launched at scale. So those are the key differentiators of the Appdome platform. Everything leads to one thing, and it's time to market. With Appdome, you can quickly deploy the right protections that you need in production without doing any code or coding directly inside of your CI/CD pipelines. And so with that, I'm going to hand it over to Dean. And Dean, so my first question to you is, what are some of the problems with existing mobile bot defense?
Yeah, thanks so much, Janneman, for the introduction. Speaking with customers, we really started to understand what their challenges are in terms of mobile anti-bot protections when it comes to backend APIs. And when you think about security in general on the internet, specifically mobile, there's always the concept of client and server. Okay, there's a client communicating with the server. That server is generally an API because in a mobile world, they're only really communicating with APIs, and those APIs have to be protected. Ultimately, without protection, they're open to the world. There needs to be some protections there. And so that's where we found that, quite often there are WAF deployments that come into play there. And talking to our customers about WAF, we came up with a product that really addresses challenges in WAF in three key areas here. So firstly, performance of a WAF solution, and I'm talking any WAF. We're completely agnostic to WAF. We support all WAF vendors. But what we find is that WAF vendors really put a strict limit on the number of hosts or endpoints that WAF can protect. Okay, and so you'll find that's common across most WAF vendors. And when you're trying to scale up, if you're scaling up your network, you may be building more APIs, that does put a performance limitation on how you can scale that out. Additionally, the second area is compatibility. When we think about WAF deployments and most WAFs out there, they're just not designed for mobile. They're designed for a web-based world and just not really designed to handle the increase of mobile traffic. And if you look at traffic today and even past many years, the growth has been really in mobile. And so you end up with a large mobile deployment that really isn't completely compatible with the security that your existing WAF is providing, because it's not designed for mobile. And so in order to get around that, there's options where WAF vendors may want code put into a mobile app. I'm going to talk a little bit later about that and the implications of doing that. But at the end of the day, you're in a situation where the mobile traffic is simply not compatible with the protections that existing WAFs offer. And we do understand that WAF deployments are not made overnight; they're built over time. And so you end up in a situation where you really don't have an agile WAF deployment. You're really tied to a specific WAF vendor or a few WAF vendors, and you really have to adopt and design your mobile around the limitations that they have in terms of protecting against bots. And so Appdome came up with this solution. As Jan said before, we are a one-stop shop, and that one-stop shop is everything to do with mobile app security. We know it very, very well. We're the best on the planet in mobile app security, and that also extends beyond to API security as well. So that summarizes the 3 key areas. And again, this is across all WAF vendors. We're completely WAF vendor agnostic. Okay, next slide, Jan.
So before I go into that, Dean, that kind of leads me, great overview, by the way, but that leads me to the big question, okay? You just highlighted what is missing in existing WAF solutions. What do brands and what do app makers need in order to build true mobile bot defense?
Another good question. Thanks, Jan. So this leads us into where Appdome fits into this. And as I mentioned before, we are the mobile app security specialists. We are the best on the planet for that. When we talk about API security and anti-bot solutions, Appdome's approach to this is really providing you, the customer, the ability to give your WAF, and that's any WAF, real information where your WAF can then make an intelligent decision as to whether that's a real connection or a fake connection or a high-risk connection. Okay, and so there's a multi-layer fingerprint set of metrics that we include in the payload from the app, from your mobile app, that the WAF can then look at and understand what is the security situation or the threat situation of that particular mobile app. Okay, and so you can then really decide based on your policies what connections actually make it all the way back to your API. Okay, that includes full session risk information, what type of attacks the device is under, what is the security situation of that device, is there malware on there, is it coming from an emulator, simulator, is it coming from a bot farm? Essentially, is it not a valid authenticated connection from your mobile app is ultimately rejected. Or you may decide that based on the threat information that we include, you may want to restrict activity from that device so that it has some type of limited functionality rather than being able to communicate with your API. In addition to that, there is bot intelligence provided as well. Things like geolocation, source of the attack. There's many, many layers of telemetry that we include. Longitude, latitude, and other metrics about the device, operating system, hardware manufacturer, etc. So we approach it in really 3 ways. We provide you rich information, very rich information to your WAF so that it can make that decision as to whether that's an allowed connection or it's a high-risk connection and do something else. But ultimately, it stops that connection from reaching your API in the first place. Okay. Great.
We've talked about the differences between a traditional WAF environment and a mobile bot solution that is optimized for mobile. But how does Appdome's mobile bot solution, or how should a true mobile bot solution, how should that stand out?
Another good question. So with existing mobile bot solutions, as I mentioned before, they're not really designed for mobile in the first place. So that's the first limitation that we see there. And for the folks on the call that are familiar with Appdome, and as Jan went through before in the overview, we're actually built into the app itself. And that's not SDK based. So I want to be quite clear about that. We're not a wrapper around the app. We're not an SDK. We're actually built into the mobile app via the Appdome build system, which I'll show you very quickly later on. But that puts us in a very, very unique position, because if we're in the app itself, then we have access to a lot of telemetry, including threat telemetry. And so that gets us to the first point, fingerprint depth. So as I said before, there's a vast array of telemetry that we're going to include in the header information of the API request that will then make it to your WAF, and your WAF can read that information and make a distinction as to what the threat risk is of that connection. There's thousands of different metrics that we provide to the WAF for the WAF to be able to make that decision. Whereas if you look at existing solutions today, there's really either no information in the app at all because that particular WAF vendor is not in the app. And so that anti-bot solution can really only make decisions based on the IP address of where the request is coming in from, maybe the structure of the API query, but it's very limited in terms of the depth of information that the WAF can use to make an accurate, zero false positive decision on that connection. And so that leads into the connection risk. So connection risk is based on a number of different metrics. You can decide based on the metrics that we provide, based on the telemetry that we provide to the WAF, you can decide what you feel is a high risk connection, medium risk connection, or a low risk connection. So the third point is performance. I mentioned before that existing WAF vendors really put strict limits on the number of endpoints behind them that they can protect. And so when you want to increase that, you need to provision more endpoints, etc. That becomes a bottleneck. That doesn't occur with Appdome. We scale to unlimited endpoints behind the WAF. In fact, you don't really even need to tell us if you're scaling out the number of protected hosts. You can just do that. The information that we provide is built into the app, and that's sent to the WAF. The number of endpoints is outside of what we're concerned about. You can scale to any number. The fourth point, sorry, is the enforcement options. So we're in the app. Okay, we're not deploying servers. There's no servers for us to deploy into your network. There's nothing for your WAF vendor to integrate into Appdome. That is not required. The information that we provide and what we do is we're actually built into the app, and that's done the same way as every other Appdome protection is done, through the same interface or API or CI/CD integration. That information is built into the app, and then you can enforce that on any WAF that you're currently using. If it's a single vendor, hybrid, on-prem, whatever it is, you can integrate that directly into that WAF with no limit on any number of APIs behind that. Now, this also ties into the ease of implementation. Again, we're not an SDK vendor. We don't provide SDKs. Again, we are a build system, and so the protection and the information goes into the app exactly the same way as other Appdome protections, which are outside of the scope of this call, but things like root detection, anti-tampering, anti-debugging, secure communication, etc. We build the anti-bot protections directly into the app in the same way. Very, very easy. Intelligence and monitoring, again, is included as well. I've got a slide on all of the telemetry that we include, but that is part of the request. So every request from an Appdome protected app with our mobile bot defense built into it will have that intelligence included in the header information that your WAF can then make use of. Finally, hardening and self-defending. This goes in conjunction to other Appdome protections. While we're talking specifically about bot defense and anti-bot, this works hand in glove with all of the other Appdome protections that you can avail on the portal. So again, things like root detection, OS integrity, secure communication, anti-fraud, anti-malware. There's something like 150 or 160 different specific protections that we can put into the app, in addition to providing the anti-bot API security.
Great, Dean, thank you. I know this was a lot of information that was given to everybody. So I think we have a couple more detailed slides on each of those things. So that'll give Dean, you an opportunity to kind of repeat what you said, but also for the attendees to better take in all of the information. So I think the first slide that we have is around fingerprinting. So can you revisit again a little bit why fingerprinting is so important?
Yeah, absolutely. This is a really good slide. What you're looking at there, just firstly on the right hand side, the white box, that is actually a screen grab from our portal. That is the Appdome system where you would go in and you would configure and set up the anti-bot or mobile bot defense protections. And
you're going to do that in a little bit in a demo, huh?
Yeah, time pending, of course. Yes, I'll absolutely show the audience that a little bit later on. But what we've got here are two important points. Firstly, everything in Appdome in the portal is really a toggle switch. It's that simple. So every protection that you want to enable, including mobile bot defense or anti-bot, is a toggle. You start up by simply switching the toggle on, and that will enable the protections. Furthermore, what's highlighted here on the screen there, we've highlighted some certain areas, and there's a blue arrow. Is we include, it's not just about including telemetry that is negative or bad. We actually include positive information as well. And so this is a lot to try to understand. But in addition to sending threat information and telemetry that there is some type of security situation with this device, we actually have the ability to send you, this device is operating okay. And that's information that would be outside of using the app. It wouldn't be forcing an API query, but we can proactively send your WAF telemetry saying that this device is actually okay. All right, and that's information that you can then preemptively apply policy around. So what we've highlighted there is a couple of secrets. They're random strings, so you don't have to read those closely, but you can configure them. The first one is a device protected secret. So if this device is secure, it's not under attack. So it's not under an MITM attack or anything like that. There's no malware on the device is a secure device. We periodically send you a heartbeat to say that. And so the heartbeat can be every second, 1,000 milliseconds, or 2 seconds, 5 seconds or less, whatever you decide that to be. But we can send you that telemetry, or the app will send you that telemetry, so that you know that that device is not currently under attack. And it's important to understand that this is really not just a new product to market, it's really a new product category. This doesn't exist anywhere else in the concept of API security. Next is the device compromise secret. Okay, so if there's something wrong with that device, and by wrong I mean it's under attack, or there's malware on there, or some other situation that means there's a threat to your app on that device, then that secret will change. Okay, and then you can see ahead of time that you're now getting signals from this device to suggest that there is something wrong with that device, and you can act ahead of time. You will have policy in place, but the policy will enact ahead of time before the user is actually interacting with the app. Now, there are other data points on there. So MTLS pre-auth, I'll jump to that one really quickly. MTLS stands for mutual TLS, which is it's actually a pre-authentication step. It is optional, but if you think about connections coming into your WAF today, there's not really an authentication step for that. And I don't mean API authentication, so things like username and password. I don't mean that. I mean actually authenticating directly with your WAF. And so with MTLS on Appdome, you have the ability to deploy certificates directly into the app, and then of course onto the corresponding WAF, where they can do a mutual pre-authentication before proceeding to any other processing of requests. So with that, in that situation, if you think about lots of requests are coming into the WAF, a lot of them are making it back to your API because they're not being stopped beforehand. But if you had the ability to do a pre-authentication step, then that's going to eliminate effectively anything that is not your app. Okay, the certificates cannot, under any circumstances, be extracted from the app. They simply cannot. So when that request comes in with the correct certificate and that handshake passes, mutual handshake, not just one way, then you can be confident that that is actually your app that is then connecting to your WAF. So future policy or future requests can then be processed or rejected.
Okay, cool, thank you. I think the other one that is really important is the ability from a policy configuration, rapid policy configuration standpoint. Can you dig into that as well, please? Absolutely.
Now, again, this is another screen grab from the portal. This section is actually directly below the section you saw before. So there's only one tab that's broken into two. So the first point is risk. Okay, what constitutes a risky connection to your API? And it can be a number of things. We provide all of the information. We provide all of the telemetry, but you have the flexibility of deciding out of that telemetry what constitutes a level of risk. Okay, so there's a standard device connection risk, which we really say is the base level protections of Appdome. So things like MITM, is the device rooted? MITM stands for man in the middle attack. It's a little bit of a sexist term these days. It should be person, but MITM attack, is the device rooted? Does it have Magisk on there, which is a root hiding tool? Is it running on an emulator? Is it running on a simulator? So some of those really core security threats that we would include as a standard risk information. Furthermore, there is an advanced option where you can see, okay, are there auto clickers on the device? Has the customer inadvertently installed malware that is actually running auto clicker programs on the device? So you can get that information. Is it under some other type of attack, some sort of dynamic instrumentation attack like Frida, or are they trying to inject code in it? So the number of different threat scenarios is almost countless, but the point is that information is bundled into the request, and the request is obviously encrypted and then sent to your WAF, so your WAF can then make that decision. And the final point is that comes under, so there's two parts to it. There's actually the threat information, and then there's a lot of additional metadata that we include as well. I think it could be the next slide on the metadata. There are things like hardware version, operating system, location of the device, longitude and latitude is included in the metadata as well for you to use how you decide to use.
Yeah, that slide is in a little bit. I think the other thing that you talked about was the importance of hardening the defenses themselves. So to defend the defenses.
Yeah.
Can you elaborate on that?
Yeah, okay, so great question. When we think about data really has, two states are shown there, but there's really three states. I need to say three just to complete the story. The first state is data in transit. Okay, we all know about data in transit. There's a packet going from client and a packet going to server. Intermediate steps on the way, of course, but ultimately it's data in transit. We enforce that data in transit to be secure. So anything that comes from your app going to a defined endpoint must be secure. So we protect that communication from things like intercepting, MITM attacks, etc. So that data in transit piece is covered. The next point is data at rest. Okay, so when your app is running, it's writing things to the device, of course. There's some caching information that gets written. There's various preferences inside the apps. There's potentially other sensitive information that the app is writing to the device. That is all encrypted as well. Okay, we use AES 256-bit encryption, dynamically generated keys, so you don't have to do any key management to run that. It is all run within the app itself. The third state, which is actually mentioned there, is in memory. So we have data in transit, data at rest, and then data in memory. We even encrypt information that your app is storing in memory. And so if you look at other mobile app security providers, they can't guarantee security across all three states. And so as Jan said before, one-stop shop for mobile app security, data at rest, data in transit, and data in memory. And then, of course, extending to the anti-bot solution I said before. So what you're seeing here is another screen grab of the portal. Very, very easy to turn on, very easy to toggle. And down the very bottom is actually slightly outside of the mobile bot. That's the base level protections that every Appdome customer will get. Okay, and that includes anti-debugging, anti-tampering, and anti-reverse engineering. The mean time between your app being launched and an attack against your app is measured in milliseconds, not even in seconds. And so it's something like 200 milliseconds from the point that your app is launched to a bad actor retrieving it and then running, reconnaissance and trying to find weaknesses and backdoors. And so that part there is really where those protections at the bottom, in conjunction, of course, to anti-bot, will protect your app from that. Anti-debugging, reverse engineering, and anti-tampering.
And this is what I said earlier, Dean. So this is all about defending the defenses themselves.
Exactly.
And so everything you've talked about is protecting the mobile app and protecting the mobile backend. but are the defenses that you've put into the app, are they protected themselves? If they're not, a malicious actor can first attack the defenses. Once they attack the defenses, they can then launch the attack further on your mobile backend. And so that's what this means, correct?
Exactly. And a good example of that, Jan, is when I mentioned earlier, and I've said it a few times because I really wanted to resonate, that we're not an SDK vendor and we're not giving you an SDK to put into your app to provide these protections. And so when we talk about protecting or defending the defenses, some approaches are to put an SDK in the app and use that as a means to protect the app. And the first thing that the bad actors will do is go after the SDK. And there's a slide on it a little bit later on. In that approach, bad actors do get hold of the SDK because they can, and it's out there. And the first thing they do is attack the defenses, and that gets them directly around whatever defenses are put into the app, and it defeats the purposes of having it there in the first place. They can't do that with Appdome. We're not an SDK vendor. The protections we provide get built directly into the app. Bad actors have no access to them.
Okay, great, thank you. The next point, if you can bring it up, and I do think we have to speed up a little bit, Dean, just so for your information, but is everything around device connections and payload options, basically all the types of different threats and attack vectors that you can protect against. Can you just briefly discuss this?
Yeah, I'll be really quick. And so what you can see there is a list of protections that we can provide. Not a comprehensive list; it's a summary list. But when you look at attack vectors, there's hundreds of attack vectors. Appdome, we know mobile security very, very well. We're the best. I've said it a few times now. We are the best in the world at it. What you're looking at there are some of the protections that we can provide. They're actually going outside of the antibot solution, but we provide that information in the payload, in the header information, that then can combine into thousands of different threat signals that will be sent to your WAF. So you can see if your customers are under any type of attack, what type of attack it is, when it's happening, and then you can use that information to decide whether you want to accept that connection or not. Okay, and I am speeding up a little bit here, but the final point there is the application health. And so I said before, this is not all about sending bad signals to the WAF. It's not all about sending, okay, this device is under attack or whatever it is. It's also sending good signals to the WAF. So you know the vast majority of your users are not under attack. You know that the vast majority are okay. They're operating fine, and your role is to protect that, is to make sure that that continues. And so we're providing you that heartbeat, if you will, and you can see ahead of time if there are any type of threat scenario happening to that device. So some of the categories there: mobile fraud is obviously very big. Mobile malware detection, cheat prevention, OS integrity, privacy. OneShield is the base protection, and then finally secure communication. That final part is the data in transit piece. Okay, just enforcing that connection is secure, not just secure, but also going to the intended endpoint.
Okay, next point, and you've talked about this several times already, is the metadata and the payload information. So can you elaborate on that?
Absolutely. So this is metadata. Okay, now if you look at the top, there's a concept called reason data, threat reason data, and we will include that in the payload of the request, where you can see, okay, this device is, the example you're seeing there is actually a rooted device, and I can tell that by the code 6901. But that there is something that your WAF would see and can make a decision on. So this is reason code will be, this is a rooted device, and we have never had a false positive, so you can guarantee that that device is actually rooted. But if you look below, and I know it's very hard to read, there's a lot of additional metadata, as Jan just said, that we include in that package. So you can see things like the geolocation of the device, longitude and latitude of the device, of course, OS version, hardware manufacturer. You can even see whether the device is face up or face down in the request, and that's quite a powerful piece of metadata that your WAF can then interpret. How is a legitimate user interacting with the device if it's face down? And so possible, but it's just extra information that we can include in the payload for you to make an intelligent decision whether to process the policy or not, process the request or not.
So basically, Dean, everything you've mentioned the last 5 slides, if I draw a conclusion that it provides a WAF administrator, provides the cyber team ultimate flexibility in deciding the policies at the WAF level, what to do when a certain attack happens, which how to escalate that, which user to block, which user to let through, and really, as they better start to understand the threat landscape their apps are under, to fine tune that to ultimately provide a much better end user experience. Is that correct?
Correct, exactly. And the end result on the WAF side, though, I haven't mentioned this yet, is this results often in a very more simple WAF configuration, because you're getting so much rich telemetry and metadata from your app that the WAF configuration can be a lot simpler. It's looking for certain information and either allowing it or doing something else or rejecting it. And so the end result of that is any advanced anti-bot system that's currently being used by the WAF can probably be turned off, because there's no way, it's just not even possible for that to provide the rich payload information and the threat information, session risk and real versus fake that we can provide. And so the policies end up just being very, very, very simple. Either allow it, implement some other restricted policy, or reject it.
And again, getting all of this very, very detailed payload data, threat intelligence information to allow you to make those decisions is independent of the WAF. So it can work with any WAF, correct?
Exactly, 100%. I haven't mentioned any WAF vendors so far because we support all of them. Okay, I'm sure all the usual suspects would be mentioned, but yes, we support all of them. As long as they have the ability to read header information, they'll work with Appdome, and they all can do that.
Okay, great. So now, how do you, as the cyber team, know that you have correctly configured your security model, and how do you know what you are looking for? And I think that is the next thing that I would like you to cover.
Absolutely. So what you're looking at here is it's a PDF. It's an artifact of proof. Our platform, it's like a receipt. Our platform, when you go through the build process, so you can see there, number one is anti-bot on or off. And this part here, I could spend a lot of time on this, but this happens at the end. So at the end, when the app is built, there's a signing process. For those that have done development know that apps have to be signed. The end of that process is the downloading the secure app with our protections in it, but also this artifact of proof called certified secure. Now, CISOs would really only have to look at this document to say, okay, is anti-bot turned on or off? Yes, it is. And you can see that from the document, dates and times, who it was that did the build, all of the relevant information about that specific build of the app, in order to make a decision, yes, we can release that out to production or out to the relevant Play stores. And so that document there is really important, because rather than needing to, a lot of the time today, it's app will be built and then released, and then there is a pen testing program that has to happen, and feedback will come back, and then actions might need to be taken to mitigate some threats. Most likely it's the same threats all the time. And then back to developers to fix it, and then back to pen testers, etc. And so with this artifact of proof, you're guaranteed that that app on that day, that time, was built with these protections in it. And once you've cited that document, you can then effectively okay the release to production. That can cut down the time from new release to production by weeks. You can almost release an app day. In fact, you could release the new app every day with this model, rather than several weeks under current model. So that's what you're looking at there. It's called certified secure. It's an artifact of proof. We give you that after a successful sign of your app on our platform, and it can come out in your CI/CD pipeline. It can come out. You can use the portal for it, or you can automate it. Whatever works best for you. Most likely it's automated through CI/CD. So it's a very, very quick process, but guaranteed what is built into the app gives you the assurance that when that app goes out to production, Appdome is in there and the protections are there.
Okay, so this is excellent. This is really, really important. The one other thing though, you had asked, we talked earlier about how Appdome works with every WAF. So with Appdome, you can have this very, very advanced mobile bot defense that works with every WAF. So now the question that I have is the flip side. Why wouldn't that be possible with existing SDK solutions?
Yeah, very good question. Excellent question. There's a lot of words on this slide, so I will try to be as succinct as possible. The slide you're looking at there has, with second column, you can see vendor X there. We've had to remove the vendor name for obvious reasons. But what we're talking about here is a series of vulnerabilities, and these vulnerabilities weren't determined by us. Okay, these were external independent pen testers that uncovered these vulnerabilities with various SDK-based anti-bot solutions. So SDK going into the mobile app, they've uncovered various different threats and vulnerabilities related to these various SDKs. And so what you can see there, just highlighting the third and final column, the vulnerabilities really came about under different scenarios. But what this point is trying to say is, there are situations where if you have an SDK, the bad actors can get access to that SDK. And it can either be through just merely getting the APK or the app file from whatever source, unpacking it, and then getting access to the SDK. But or intercepting it through MITM. Now, looking at the Appdome solution, obviously we're not an SDK-based solution, so that option doesn't work. The RASP protections that we put in mean the app can't be debugged, it can't be tampered with, it can't be reverse engineered. So there's no way for them to retrieve any information from the app in order to mimic or replicate or any type of attack against your app. The final point there, and I am going a little bit quicker for time, is we don't rely on any third-party attestation service. Okay, all of the Appdome protections, and I'm just speaking theoretically here, we put up protections into an app, Appdome protections go into that app. Now, obviously, excluding the need for it to communicate externally, those protections will work in flight mode. Okay, so you have a protected app on a device, let's say that it's rooted or there's some other threat on there, that will actually work in flight mode. Okay, so there's no reliance on an external system or external API to enforce or implement the Appdome protection. So just to summarize, these are some critical vulnerabilities that were found by third-party pen testers when looking at SDK-based solutions. And I can think of a vendor, specifically right now that I can't mention, that actually provides their SDK on their website. So you can see the code that they would be putting into the app in a means to provide WAF anti-bot security. And it really, that code is already in bad actors, it's already in emulators. They're essentially able to fake connections to that WAF because they have access to the SDK.
Yeah, so summarizing all of this, how does this now work in reality? If you deploy an advanced mobile bot protection solution to your mobile apps that communicates with any WAF, how does this really work in reality?
Yeah, excellent. What we strive to get to with customers is exactly this, exactly what you're looking at. Very similar, very simple architecture. Your APIs on the very right-hand side in green. We want you to get to a point where only traffic in the middle, the green traffic, is actually even making it to your API. Okay, everything else is either stopped or done at the WAF level. We've simulated different or highlighted different traffic scenarios here. Everything from the first one, it's an emulator or what we call a fake app, and so those connections are coming in from a fake app. They're hitting the WAF. Header information is not there from Appdome, and so you can make an immediate decision. If the header information is not there, it must be a fake app. We're not going to allow that connection. Okay. The next one is a device under attack. So Appdome is on the device, and that app is under attack. So it could be any number of attack, MITM, for example. We're including that in the telemetry, in the information and metadata to the WAF for it to make another decision on, probably to reject, but we highlight them in yellow because it is ultimately up to you what policy you want on there. But that second one is a device that's under attack. Brings us to the third one, not under attack, secure device. That traffic is allowed. It's all green. Next one is this device is actually being intercepted by someone, by a bad actor. And so that information as well is included in the headers so that you can then make, again, another policy decision. The final one is not your app at all. That's just random traffic from bad actors. They have big server farms and they're hitting your WAF. You obviously would be dropping that traffic. There'd be no reason to process that. That's why it's highlighted in red. And each line, we've included some information as to why you would or wouldn't allow that traffic. The final one would just be rejected. So this is what we aim to get to with our antibot solution. So your API in the end is only getting real authenticated secure connections, which actually will result in quite a big drop in traffic to your API.
Okay, Dean, this has been very, very good.